The development of the universe goes beyond the Hubble sphere, with the universe expanding faster than the speed of light. However, the Hubble sphere won't continue growing forever. There's a limit to what we can observe, often referred to as the observable universe or the cosmic horizon. This boundary represents a vast imaginary shell around us, roughly 93 billion light-years wide, and marks the farthest distance from which light has had time to reach us. Beyond that, we cannot see, and no matter how advanced our telescopes become, the light from those regions simply hasn't reached us yet. But what about the rest of the universe beyond this observable boundary? How large is it? The answer remains uncertain, with competing theories and equations keeping scientists on their toes. Some propose that the universe could be infinite, while others suggest it might be up to 10 to the power of 100 times larger than what we can observe. The even distribution of matter in the universe, along with the uniform temperature of the cosmic microwave background radiation, points to the possibility of an infinite universe. Yes, you heard that right, infinite. Mind-blowing, isn't it? When we peer into the vastness of space, we're not just looking at distant galaxies. We're also looking back in time. The galaxies near the Hubble sphere are not representations of the present. Rather, they are cosmic fossils, remnants of a past era billions of years ago. It's like a time machine in the sense that we're not physically traveling through time, but simply observing it as it was. According to our cosmological model, about 13.8 billion years ago, the entire visible universe was compressed into a tiny point called a singularity. That's the standard story of the Big Bang if the universe is finite. However, if the universe is infinite, which it seems to be, then the Big Bang wasn't a localized event. It happened everywhere, even beyond our current observable horizon. The original galaxies didn't form in a specific location in space. Rather, the universe's grand opening act unfolded everywhere, including beyond what we can see. But the real question is, what or who caused everything to come from nothing? Einstein was initially skeptical of the Big Bang idea and preferred the notion of a steady-state universe that had existed forever. Eventually, however, he accepted the Big Bang theory. Yet, some scientists now suggest that the singularity wasn't the universe's beginning, but more like an announcement of its birth. Just when we thought we understood the universe's origin, the James Webb Space Telescope came along and stunned us with unexpected findings. Recently, it discovered a distant galaxy, F200b45, that could radically change our understanding of cosmic history. This galaxy is so far away that, if confirmed, it could challenge our familiar 13.8 billion-year-old timeline of the universe. Webb has also found galaxies that shouldn't exist. Massive galaxies appearing only a few million years after the Big Bang, an astronomical speedrun that defies our current knowledge. Even more astonishing, Webb spotted early black holes forming just 700 million years after the Big Bang, merging together, possibly explaining how these cosmic vacuum cleaners grew so quickly in their infancy. These discoveries are causing a stir in the field of cosmology. The universe might be older than we thought, or it might never have had a beginning at all. Imagine if our universe were like a favorite storybook that never had a first page. It's always been there, just unfolding through different chapters. As we gaze deeper into space, the idea of an infinite universe starts to make more sense. If the universe appears infinite in both size and age, then the Big Bang might have been just a sudden expansion rather than the initial scene. Yet this is just speculation and we need more research. Does this eternal universe concept align with our current understanding of science? Can it explain the chaotic series of events during the Big Bang? It's also believed that there may be around 2 trillion galaxies in the observable universe, but astronomers are still left wondering how much more lies beyond what we can see. Virginia Trimble, an astronomer at the University of California, puts it this way. The universe has always been slightly larger than what we can observe. It's like the universe is playing hide and seek, and we're desperately trying to figure out where it's hiding. Nobel-winning cosmologist John Mather from NASA explains that we've already looked as far as we possibly can, catching a glimpse of the glow from the Big Bang at the very edge. But this isn't the end of the story. The universe keeps expanding, and we may never fully know how far it goes. As they search for answers, cosmologists have borrowed a page from ancient Greek mathematician Eratosthenes, trying to determine the shape of the universe to solve this mystery. Is the universe like a giant saddle, a round sphere, or a flat sheet? The saddle-shaped idea has few supporters, but the idea of a spherical universe feels comfortable to us. Einstein referred to this as a closed but unbounded universe, but in the late 1980s, observations of the cosmic microwave background radiation suggested that space is actually flat, with no curvature. This flatness means that one could travel in any direction indefinitely and encounter galaxies without end. While this theory fits well with current cosmological models, it raises questions about the universe's boundary and what lies beyond. Virginia Trimble compares this challenge to trying to figure out whether a pizza is infinite or if it has an edge, prompting more research into the universe's edge and what lies beyond it. Some theories suggest that the universe could be a bubble within an expanding multiverse, possibly with an edge and different physical laws on the other side. Scientists are looking for a theoretical model to determine the vastness of the universe, much like how the Higgs boson was predicted before it was discovered. These grand mysteries continue to fuel curiosity and research, encouraging further exploration as we try to unravel the universe's secrets. Imagine a place where stars stop shimmering and universes come to a halt. What hidden secrets could lie beyond this newly discovered boundary? Are we on the verge of unlocking the greatest mystery of all time? Or is this just the beginning of an entirely new chapter in our cosmic journey? Well, it seems the James Webb Space Telescope has discovered the edge of space itself. Yes, you read that correctly, the final frontier might not be as infinite as we thought. But hold on a second. How can space have an end? Wasn't it always supposed to go on forever? Let's dive in and figure out what's really going on. When I first heard this news, I was absolutely excited to uncover one of the universe's many secrets. The James Webb Space Telescope has been doing exactly that, flipping our understanding of the cosmos on its head with just 12 hours of observation. In this short amount of time, it revealed things that left us staring in awe and scratching our heads. Now let's picture together just how vast the universe truly is. Imagine your mind expanding as you consider the farthest reaches of space, all the way to its edge. Let's figure out just how far the James Webb Space Telescope can really see into this cosmic expanse. So, jump aboard our imaginary superfast spacecraft and let's begin. We won't waste time as we speed through the solar system, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We've now covered 100 astronomical units, and we reach the boundary of the heliosphere. Beyond this point lies interstellar space, the domain of Voyager 1 and 2. As we push further, we approach the Oort cloud, a region filled with space rocks, located 200,000 astronomical units from Earth. The space here is sparse, and we effortlessly navigate through the rocks, entering complete darkness. We zoom past distant stars and planets, reaching the outer limits of our galaxy in mere minutes. No more interstellar dust, only the bright lights of other galaxies ahead. And then we realize, our universe isn't infinite. It has a boundary located 10 billion light-years away, and there might be other universes out there. The first supervoid, stretching 1 billion light-years wide, could be evidence of a collision with another universe. But how do we reach these other universes? Black holes might hold the key. They're mysterious, warping both space and time. Some scientists even propose the existence of white holes, the opposite of black holes. The idea is that these could act as gateways to different universes. Remember the Big Bang back in 2006? That strange burst of energy could have been the birth of a white hole, which was destroyed almost instantly. Now let's talk about the Andromeda Galaxy, which is hurtling toward us at 68 kilometers per second. Don't panic. It won't collide with us tomorrow. But when it does, things will get interesting. We might witness a cosmic crash, or our solar system could be tossed into deep space like a tennis ball flung on a rope. Fast forward to the merger of the two galaxies, and the black holes at their centers begin a cosmic dance. Eventually, they merge into a supermassive black hole, emitting energy and forming an active galactic core visible across vast stretches of space. Then there's the South Pole Wall, 500 million light-years away, containing a quadrillion stars. Not to mention the Hercules Corona Borealis Great Wall, a colossal superstructure 10 billion light-years wide. Let's not forget the massive quasar at the heart of a galaxy, 6.1 billion times the mass of our Sun, and the observable universe itself, home to over 500 billion galaxies, each with billions of stars. Yet, there's a void called the Aratus supervoid, or the cold spot, a billion light-years wide. Some believe this might be the result of a collision between two universes, with material being torn away as the two bubbles collided. Now, picture the universe as a massive bubble, and imagine countless other bubbles or wormholes, each potentially leading to other universes. Think of a wormhole as a shortcut through space, like folding a piece of paper to connect 2 points without having to cross the entire sheet. The idea is that falling into a black hole could be survivable if it's large enough, as gravity's pull would increase gradually, avoiding the dreaded spaghettification. Who knows? You might even end up in a different universe with its own set of physical laws. For now, though, this is just a wild hypothesis. Imagine, for a moment, standing on a starry night and gazing at the twinkling lights above. They may seem evenly spread out, but in reality, they're part of something far larger, a vast, infinite web connecting galaxies across the universe. Using the James Webb Space Telescope, cosmologists have accidentally discovered what could be the oldest strand of this immense cosmic web. This ancient fiber, made of gas and stars, stretches across an astonishing 3 million light-years. It's a tightly packed cluster of 10 galaxies, and it was uncovered through data from the James Webb Space Telescope. Shuni Danieli, an astronomer from the University of Arizona, was amazed by the length and thinness of this fiber, saying, "I expected to find something, but I didn't expect something so long and distinctly thin. It was like stumbling upon a hidden treasure in the cosmic vault." This ancient fiber dates back to just 830 million years after the Big Bang, essentially the universe's infancy. And anchoring this massive structure is a supermassive black hole, a highly luminous object that acts as the anchor for this vast cosmic fiber. The team behind this groundbreaking discovery is part of the AIM project, which stands for Spectroscopic Study of One-Sided Emissions in the Reionization Era. Their mission is to understand how early black holes influenced the development of galaxies. One of the early universe's 5 quasars led the team to this incredible find. Fan Wang, an astrophysicist from the University of Arizona, is particularly excited about this discovery, as it opens up new possibilities for studying the universe's first supermassive black holes and their role in shaping cosmic structures. In short, the James Webb Space Telescope is revolutionizing our understanding of the universe, revealing incredible structures, cosmic fibers, and black holes that anchor the very fabric of space. It's just the beginning of many astonishing discoveries ahead. The earliest filamentary structures ever observed, linked to a distant quasar, were discovered in a way that felt like stumbling upon an infinite treasure map, unlocking secrets of the universe's early days. Here's where it gets really fascinating. Scientists believe black holes played a crucial role in forming this vast cosmic web. Imagine black holes acting like magnets, drawing matter toward them with their immense gravitational pull. But wait, they also periodically expel material into space through what are known as infinite winds. Gravity, however, is the glue that keeps the strands of stars and dust connected, even as the immense winds attempt to pull them apart across the vastness of the universe. So, what will happen to this ancient web? Researchers have an intriguing theory. Over time, this enormous structure could merge into a cluster of galaxies, similar to the Coma cluster, located about 330 million light-years away. It's like watching the universe evolve, creating its own magnificent masterpiece over billions of years. When the James Webb Telescope focused its mirrors on a small patch of sky, it captured far more light and galaxies than expected. Massive, brilliant ones. This discovery has left scientists scratching their heads and exploring several possible explanations to make sense of the cosmic mystery. One possibility is that stars and galaxies formed differently and more efficiently in the early universe. Picture a dark room with few stars and galaxies, making it easier for them to form rapidly. It's surprising but not a complete rewrite of our current understanding. Another option is that the light we're seeing isn't from stars, but from enormous black holes. Instead of a galaxy full of stars, we could be witnessing galaxies illuminated by these mysterious black holes. If true, this challenges our understanding of how many of these cosmic beasts existed in the early universe. The most extreme possibility is that our understanding of the universe's fundamental laws, cosmology, may be incomplete. While this idea may be radical, it could shake up everything we know. And then there's the wild card. There might be some aspect of the universe that we haven't even considered yet. Why does all this matter? It's about finding our place in the universe and understanding how we got here. If we're missing something critical in this narrative, solving the puzzle becomes nearly impossible without all the pieces. As we delve deeper into this mystery, more questions arise. Recent findings from the James Webb Telescope have shown us a new perspective on the size of the universe. Perhaps we've been mistaken. A groundbreaking paper recently claimed that the telescope observed objects just 120 million years after the Big Bang, if the Big Bang even occurred. This discovery challenges the very foundation of the standard cosmological model, suggesting the universe may not be as old as we once thought. In fact, what Einstein might call endlessly old might turn out to be wrong. Our instincts have been playing tricks on us, and we're realizing just how little we know about what's out there. The James Webb Telescope peers deep into space, trying to see the farthest reaches, up to 46.5 billion light-years away. This is what we call the Hubble radius or Hubble sphere. The most distant galaxy ever observed by the telescope, the galaxy named Maximum 0647 JD, existed only 450 million years after the Big Bang, and it's still within this Hubble sphere. Now, think of the universe as a balloon constantly expanding. Not only is it growing, but it's also evolving in ways we are just beginning to understand.